do we care about one-to-oneness? Why is this an important characteristic of functions that we would want to look at? Becomes clear with the next definition or two here. The inverse of a relation, a function or other relation, is the relation. For a relation, just think input-output, so bunches of x and y pairs. The inverse of a relation is the relation you get by exchanging x's and y's. That's kind of a definition I'm writing down on the fly, and it's a little bit rough. That won't be as pretty as the one in the book. Basically what I mean by that is an inverse is the relation compared to this one. Let's see, the inverse of this relation is 7, 2, 7, 1, 3, -1. Just reverse x and y, or you can kind of see an inverse as turning a relation on its head, and whereas you used to take the inputs and go to specific outputs, now you take those outputs and go back to the original inputs. Now let's see, if you look at this inverse of this very simple relation, notice that although this one was a function, it is a function but not one-to-one, this one is not even a function, because when you reverse the x's and y's here, you get ordered pairs that are trying to take 7 to more than one output, right? So here's an input for which there are 2 different outputs. This would fail the vertical line test. So if you have a function that's not one-to-one, or a relation that's, that does not have unique outputs, then the inverse is not going to be a function. So the reason why we're really interested in one-to-one functions mainly is, note, if f of x is one-to-one, then its inverse, and we're going to write the inverse of f inverse of x. This -1 here looks for all the world like an exponent, but it's not really an exponent. It's just notation that means inverse. So read this, f inverse of x, f inverse of x. If f of x is one-to-one, then its inverse, f inverse of x, will be a function. Actually, I don't want to use this notation unless f inverse is a function, right? I've written it in function notation. So I probably should have said, if f of x is one-to-one, then its inverse will be a function, and we will call that function f inverse of x. Let's take a quick look at a couple problems from the activity, and I'm going to dim these lights and maybe do a little